In this chapter, we are going to be able to say that I can find the rate of change and determine the slope of a line. So before we actually are able to do that, we are going to be going through a little bit of vocabulary with this. We have three words that we are going to, well, more than three words, but three different things that we are going to try to define today, or try to figure out the difference between. We have the rate of change, we have something called the average rate of change, and we have something called slope. Okay, so rate of change. What is rate of change? The rate of change is a ratio. Is a ratio that compares how much, that's an ugly M, how much one quantity changes on average relative to the change in another quantity. So the rate of change is a ratio that compares how much one quantity changes on average related to the change in another quantity. Let me make sure. Get rid of that extra thing. So that is what the rate of change is. Rate of change is we are comparing two things. We are trying to figure out how much it changed in relation to each other. The average rate of change is very, very similar. Okay, rate of change typically is more of a linear thing. Average rate of change, it does not have to be a linear equation or a linear graph. We just look at the two specific spots. Okay, and we're going to look at what that means. So average rate of change is basically the same thing. We have a formula for that. We say that this is going to be f of b, and we'll get into function notation a little bit later, minus by f of a divided by b minus a. By the way, this equation should look familiar because that is actually the equation for slope. Slope, remember, slope is for a straight line, and this is our change in y over change in x. In other words, you also have seen it as y2 minus y1 over x2 minus x1. If you were to just replace a function notation with y's and x's, it's the same thing. Okay, so average rate of change is just another way of saying slope. We're finding the slope between 2 points. Main difference is that average rate of change does not have to be a linear equation that you're finding the average rate of change of. Okay, so your graph could be all over the place, but we're focusing in on two specific points and trying to find what the average is if it was a consistent thing going on. Okay, so that's the main difference. So main difference between these things is that the rate of change is a general concept. Okay, how fast one thing changes compared to another. Average rate of change is technically slope between 2 points. For a function, it does not have to be a line. And slope is, of course, a constant rate of change. It is a straight line. Okay, so slope is the straight line. Let's look at an example of this. In 2018, Jordan's monthly rent was $950. By 2024, the rent increased to $1,250. What was the average rate of change in rent per year if the rent continued, and also if the rent continues to increase at the same rate? What will be the rent in 2027? Okay, so we are going to figure out what the average is between these 2 points. We're going to find the slope between these 2 points. Then we're going to take that information and make a conjecture about what it's going to be in 2027. So let's figure out what our x value is and let's figure out what our y value is. Remember, whenever we're dealing with this, we want to know which one's independent, which one is dependent. So independent is the years. The years do not depend on anything. So the years are going to be our x values. So 2018 and 2024, let's call this one x1 and let's call this one x2 for the years. Remember, we're just finding the slope. If we're finding average rate of change, we're finding the slope. And I'm going to use just a slope equation because it's a little bit more simple. And you guys have seen it before. It's a little bit more recognizable to you. The other thing, the money. Money is dependent, or the price of rent is dependent upon the year that you are living in. As years go on, the rent is going up. At least it appears to, at least in this example. So the money is going to be our y1 and our y2. There we go. Let's set up our slope. So slope of this, change in y over change in x, equals to 1,250 minus by 950 divided by 2024 minus by 2018. Okay, let's go ahead and subtract these numbers. 2024 minus by 2018, that is going to be a 6-year gap. All right, 6 years have passed. 1,250 minus by 950 is going to end up to be $300 difference. Dividing those, that's going to be $50 extra each year. For every year that she's living in that house and paying rent, she's paying $50 extra for that year. So 2018, she'll be paying that $950. 2019, she'll be paying $1,000. 2020, she'll be paying $1,050, and so on, until you eventually get to that $1,250 in 2024. So the average rate of change is about $50 more each year. And by the way, that may not have been the actual reality. Maybe she paid a little bit less the next year, or maybe she did not pay an extra $50 the next year as it went along. So remember, it's just the average of these two very specific times. So $50 extra each year. Now let's take this and continue with what the question is asking. That is the average rate of change. The other part of the question is, if the rent continues to increase at the same rate, at this average rate of change, what would be the price in 2027? Well, let's just take this in terms of the 2024. How many years would have passed from 2024 to 2027? 3. So we have 3 more years that pass by. If we take those 3 years, times that by the $50, we'd expect that to have an extra $150 added on top of what she paid in 2024. Does that make sense?
Yes.
Okay, so we go ahead and add whatever she had in 2024. We have the 1,250. Add that together. We have 0. We have 10. Carry the 1. 1 plus 1 plus 2 is 4. So this would be 1,400 that she would expect to be paying in rent by 2027 if this rate continued in this fashion. So that is the answer to that example. We have the average rate of change and also the other part. So there was kind of 2 parts to this. Here's a second example. Maria is training for a marathon. In 2019, she could run 5 miles without stopping. In 2021, she could run In 2019, she could run 5 miles. In 2021, she could run 9 miles without stopping. And by 2023, she could run 17 miles without stopping. Find the average rate of change for the number of miles Maria could run per year between 2019 and 2023. The only years we are interested in is this 2019 and 2023. Those are the only years we're interested whenever you are looking at average rate of change. So this 2021, we don't care about. That's just extra information. As it is, the slope, the rate at which it changes, may not be what actually happened in reality. We just want to know what the average of it is. So if it were following a linear path, what would it have been? Basically, that's what we're asking. So 2019, remember, years are independent. This would be our x1, and 2023 would be our x2. And the miles depends on what year it was. Some years she was able to run farther than other years. So this 5 miles is going to be our y1. This 17 is going to be our y2. Set up our equation. So we have 17 minus by 5 on top, and we have 2023 minus by 2019 on the bottom. 17 minus by 5 is 12. And 2023 to 2019, that is a 4-year gap. Divide. 12 divided by 4 gives us 3. So on average, she should have been able to run 3 extra miles without having to stop every single year. Okay? So that is our average. That answers the question. But I want us to look at what actually happened. Look at reality. See if it actually followed that pattern. So 2019, she ran 5 miles without having to stop. If we wanted to continue this, 2020, she should have been able to run 8 miles. And 2021, she should have been able to run 11 miles. Notice reality was just a little bit different than what the average was saying. Some years might have been better than other years. Maybe she had something going on where she just couldn't run as well that year. So keep in mind, average rate of change, we're just looking at 2 specific points and asking if this was a linear equation, what would be the average that would have occurred if we were going at the same rate? Oh, we have a picture for this one. Refer to the graph below. Find the average rate of change of the number of electric cars sold and the number of hybrid cars sold in the U.S. from 2015 to 2025. This is not accurate. I'm just going to say that right now. This data is not actually what happened in these years. This is just a quick example for what we could have. Okay, so this is not accurate at all, not historically accurate in any way. So find the average rate of change of the number of electric cars sold and the number of hybrid cars sold in the U.S. from 2015 to 2025. We want to compare the rates. So notice we have 2 graphs. The red graph is for the hybrid cars, and the blue graph is for the electric cars. Remember, average rate of change, 2 points that we're trying to find the average of. So we're interested in 2025 and 2015. I know I said that backwards. 2025 and 2015. Those are the 2 years that we are interested in. So we're only looking at this part of the graph and this part of the graph. Okay? Nowhere else. Everything else does not matter in this case. Okay? We just want to look at those. Because you notice there is a little bit of upswing, and then we go down, then we are at an uphill in revenue. We are selling more cars that way. Okay? So let's first look at the hybrid. We're going to use red for this. 2015 hybrid, we had the 1,500. For 2025, we had 2,500. Okay? So in other words, remember the amount of cars is going to be dependent upon the years. So we have our Y value, which is 2,500, minus by 1,500, divided by the 2 years. 2025 to 2015, that is a 10-year gap. So I'm just going to put 10 underneath that. Subtracting these, this will be a difference of 1,000 divided by 10, which gives us 100. So we have an average rate of change between 2015 and 2025 being 100 extra, 100,000 cars extra per year. Okay, so if we were to draw a straight line between these 2 points, this is what it would have been. This would have been the average. Notice it's not what reality said, but it would be what the average would be over those 2 within those 2 periods. Okay, we're just looking for the average. 2 points, looking for the average. With the electric cars, I'm going to draw that. We can come back to that. Electric cars, we're at $2,000 for both years. So $2,000, or sorry, not $2,000, 2,000 cars sold minus by 2,000 cars sold divided by those 10 years. That's 0 divided by 10, which gives us 0. So according to the average rate of change for the electric cars, we did not sell any of those extra years. The average rate of change would not have changed at all. And if we were to continue this, we would say, okay, well, electric cars, we are not going to see any increase in the sales of electric cars. But the sales of the hybrid cars, we are going to see an increase as time goes on. That's according to average rate of change. So we do need to be careful with how we apply it. Okay? If we're looking back at other years, it's great because it tells us how much we should have did if we went on an average rate. Okay? So that is some examples of average rate of change. And I spoke through how to compare them. Okay? So the hybrids, they increase by 100,000 cars per year, while the electric, they did not increase. If people were looking at this, if this was accurate data, people would say hybrid cars are the way to go, not electric. But of course, it may not be like that. Okay? So that is average rate of change. Let's just talk a little bit about slope. You guys have all seen slope before. So we're just going to go through this real quick. Find the slope between these 2 points. Let's just label x1, y1, x2, y2. We've been doing slope already. So what we're going to do is just go 5 minus by 3 over 8 minus negative 7. 5 minus 3 gives us 2. And minus a negative is a plus, so 8 plus 7 gives us 15. So slope, I'm good with slope being written as a fraction, because it tells us more than if we write it as a decimal. So that would be our slope for those 2 points. It's a positive slope, and we would see that we would be increasing. One thing I do notice, did we write down all the information correctly at the very start? Be careful. This is a negative 5, not a positive 5. So one thing has to change. That has to become a negative. Make sure we have everything else the same. This 3, still 3. Remember, with slope, we are minusing, so that's why we have a minus there. We have an 8. We have minus negative 7. So this will change our answer to be a negative 8 on top. So our slope is a negative 8 over 15. That is our answer. Make sure we double check ourselves so we end up with the right answer. You could also graph it and be able to find the slope that way too. Both ways work. Let's just do this one really quick. We have, I believe, 2 of these. That we're just going to find it with a picture. You guys have all done this in Algebra 1. So let's go ahead and just find some nice points. A nice point that pops out to me is the y-intercept, that one. Another nice point is here, and here, and here. These should be consistent, by the way. Notice we are changing in y by going up by 1, 2, 3. And we are running by 2. So rise by 3, run by 2. If we were to follow this along as well, we would see that it's a rise by 3, run by 2. Rise by 3, run by 2. Rise by 3, run by 2. You guys have seen this before, so I'm not going to spend too much more time on that. Moving on, last question. Let's find some nice points. Find some points that we know what they are. Okay, find some points that we know where it is. So one point is right here. Another point could be here. And let's just see if we can find as many of them as we possibly can to figure out if it's consistent. It should be consistent because it's a linear equation. So we go down by 1, minus 1. And we go over by 1, 2, 3, 4, 5, 6. If we went down by 1 over by 6, down by 1 over by 6, it's still consistent. It's linear. So this is a slope of negative 1 over 6. Remember, the y value goes on top. And that is the answer for finding the slope with a graph. We talked about finding slope with points. We talked about average rate of change, how the average, it does not have to be linear, but we're looking at two specific points within that, which would be linear between those 2 points. And at this point, we should be able to say that I can find the rate of change, an average rate of change, and determine the slope of a line.